Okay. Okay, let's go. So, welcome back. My name is Jeremy, and right now we are gonna try to figure out how to rewrite the next function we want to rewrite. And while trying to rewrite it, we are gonna learn a little bit more about unsafe, how to call it, and what we should be specifically very careful of. Now, if you have seen the first videos before, you have noticed that I am not too good of a programmer. So basically, I'm going to give my best. I'm going to try to do my best to make sure that the code I write is sound, but that's not for sure. If you notice anything, please drop me a comment and I'll try to make it up as soon as I understand what you're telling me about. So basically, what we have done in the previous episodes was rewriting the toLower function, and we did rewrite the toLowercase function that takes a pointer to an array of characters and a length. So right now we are gonna try to rewrite the toLowercase function that only takes a pointer to a null terminated string. So I'm gonna just go back to the code here, and we are going to try to write a test about that. Now, there is something that is a bit inconvenient in Rustling. It's that operator overloading does not exist. What I mean by that is that if I create another function that's called the same way as the first one with different parameters, we are going to run into trouble because it has already been defined. So what I'm going to do in order to be as explicit as possible is I'm going to name this one net to lowercase with length. And the new one is going to be called just net to lowercase. So what I need to do right now is update all the tests we have done so far. There is one here. I'm going to update the definition here. I'm going to probably have to update the tests and this one too. And there's probably a benchmark. Is there? No, there's not. This is good. Okay, so I'm just gonna make sure that my tests pass, because if I start writing more code right now, I might get confused and something might just not work correctly and I won't be able to understand what or why. So I'm just gonna run everything. It seems like I'm just gonna make clean to make sure and make test. Okay, my tests are passing. So that means we have successfully renamed the net to lowercase with length. Now what we are gonna do is start writing the net to lowercase function. And in order to do that, we are gonna write the tests first. I am not a confident person at all, so I'm just gonna pick a test we have written before in Rustling, and this one would be with length, and this one is gonna be the regular one, I suppose. So I'm gonna remove the parameters, and I'm gonna call net to lowercase. And we need to figure out a way for this to work and compile. So the first error we see is that there is no net to lowercase function. So let's write it together. So I basically picked the other one, and now we are gonna play around with the way we've been working lately. So here we are. We checked for the null pointer, and then we were trying to build a slice from raw parts. The thing is that from raw parts, mut actually takes the data and the length. Okay, so there are two things we know. The first thing is that in C++, oh, I'm gonna update the documentation here. In C++, what happens is that the string has to be null terminated. And by null terminated, I mean that it ends up with the \0, like something like this. Let my string equals, this is a binary string, and it's null terminated, like hello world. That's not a character, it's a string. And it's null terminated. And by null terminated, I mean it has the \0 at the end, okay? So this is what we are gonna need. And otherwise, there is no way for us to know that the string is terminated. We don't have any length. And if there's no null byte, then we can go on and iterate through the whole memory at once and just it just would never end. Okay, so what we are going to do is basically what I just said. We are going to try to iterate through the characters that we have and try to make them lowercase if possible. So how are we going to do that? Well, there's a pretty nice function I've just learned about, which is called offset. An offset, as you can see here, is a function that is unsafe and that behaves on a pointer and calculates its offset. So what we're going to be able to do with it is we are going to be able to iterate through the string until we reach the null byte, okay? So let's just try to write that together. So what I'm going to do is iterate through the string until I reach a null byte. So let's go ahead and do this. So for my index in 0, so I'm creating a range which has no boundary here. And I'm going to play around with my stir pointer. So here we have the offset, okay? And now that we have the offset, it's going to complain because that's supposed to be unsafe, I suppose. No, it's not. The only thing that is for me dereferencing it, I suppose. So now that I have this offset, I can do stuff. The first thing I want to do is check if it's the termination string. If offset is 0, then we want to return. That means we're done iterating over that string, okay? And if not, this is the actual interesting part, which is we want to make it lowercase. So if I recall correctly, I've been trying to do this here. So let's try to do some casting and see how it goes. Let's do this. Okay, so we are going to do some casting and see how it goes. The new value of stir pointer offset equals, well, what is it equal to? It's equal to something that is a C char, which we first need to convert to a U8 in order to make it lowercase, as I don't know if I can do this right now, but let's try that. As much as U8. There you go. To lowercase. Let's see how it goes. Maybe I want to dereference it. It's not even complaining. Let's see what happens. I'm going back to the lib. Okay, that's just because my linter is down. So it's saying that I'm trying to convert a U8 into an I8, and it's gonna panic. Oh, yeah, that's the unsafe cast that I've been trying to do. So the thing is, this unsafe is not too unsafe because I know that it's gonna work because since I am working on a string, uh, each character is gonna be fine. So let's try to see what's going on. Offset as I8 as U8. Is that what I've been doing? Yeah, that's what I did. Expected I8, found U8. So the two ASCII lowercase might apply. Oh, I see. It has nothing to do with it. Let's go back here. I think it is complaining because the whole line is wrong. And what I mean by the whole line is wrong is that we are supposed to have a C char on the left-hand side, and we have an I8. So let's try the SC char. I might want to restart the linter to make sure that it's working. So I'm going to reload the window and hope for the best. Maybe I get my linting back. Yeah, I got my linting back. It's awesome. So there are two things that are wrong. The first thing is that this is unsafe. All right. So if it's unsafe, it requires me to wrap it in an unsafe block. Let's do that. Okay. And this here requires an unsafe block too. I am explicitly separating the two lines. I could have written a whole block, a whole unsafe block for the for each loop, but I want to make sure that I want the granularity of the unsafe to be as small as possible to make sure that it kind of works. Okay, and it has to do with how unsafe behaves, how it actually works, and what we can do with it. Okay, so let's maybe have a little break and have a look at what unsafe is and how it works. Okay, so unsafe Rust, as you can see in the documentation, I'll put the link in the show notes. Unsafe Rust is a way to disable some of the compiler's checks. Here it's referred as unsafe superpowers. Those are basically a couple of things that you are allowed to do. And by allowed, I mean it's not. It's still going to compile. And it will give you a couple of abilities. It's going to give you the ability to dereference a row pointer, to call an unsafe function, to mutate, to access and mute or modify a static variable, which is mutable, and implement an unsafe trait. Do not consider unsafe as a way or a hack to do stuff that you're not supposed to. Unsafe is a way for you to, you're basically promising the compiler that you are maintaining the safe invariance. You are telling the compiler, okay, I know what I'm doing. There are some invariants that need to be held for my code to work. I am gonna handle them. If you do not make it, the compiler will just let you do stuff that might lead to an undefined behavior at runtime. What I mean by an undefined behavior is that anything can happen. Maybe your program will crash at runtime. Maybe it will display your password. Maybe it's gonna, I don't know, do basically anything, empty your Bitcoin wallet or whatever. So let's have a look at the Rustlang reference with respect to behavior considered undefined. Undefined refers to, so this is a list, it's not exhaustive. It's telling you that a data race is considered to be undefined. Dereferencing a null or dangling raw pointer is undefined. And everything related to unaligned memory is undefined. And there are some aliasing rule and mutating and non-mutable data. So there are basically a lot of things that you need to consider when you are dealing with unsafe code. The main advantages are that since you have unsafe blocks, you can make sure and document these blocks and make sure that the people who are calling your functions are gonna make sure that the invariants are held. So you can basically tell, yeah, so this is the function, it's unsafe because you need to make sure that this pointer is actually correct and this kind of things, okay? So in order to deal with unsafe, as you can see here, in the code, I've been using the offset function. And there is a safety chapter here telling me exactly what I need to make sure of before I call this function, okay? If any of the following conditions are violated, the result is undefined behavior. So starting and resulting pointer must be either in bounds or 1 byte past the end of the allocated object. Okay, I am iterating over a supposedly null terminating string. So the offsets I am actually pointing to are supposed to be part of the object. So part of the slice. The computed offset in bytes cannot overflow an I size. This is something I have not looked at. So basically, I want to make sure that offset is 0 or that the computed offset is not more than I size max bytes, as you can see here. So we might want to have a look, that's what they refer to. We might want to have a look at the source code of VEC and Box to see how they make this iSize max check, okay? So let's go back to the documentation on my Internet tab and try to figure out how VEC and Box do that. Rustlang VEC, let's do that. So this is the VEC documentation, and there is a call to add, which we are going to be looking at. Is there an add function? There's a push. Let's have a look at the source code of push. We write stuff. There's an add here. There's an add here. So the mutable pointer is being called at a couple of places. So here there is a couple of comments like the file length. We want to make sure that we don't panic and this kind of stuff. I think there must be a function infallible. Shift everything to make space, make sure that we have enough space, etc., etc. So here we are making sure that we are always working within the boundary checks, okay? So that's basically what I will have to make sure when I use this code, okay? So there are actually two places where I use the offset function, and I always use it with the same way. So it might actually be possible for me to make it a bit more readable and place everything directly in the unsafe block here, okay? So I'm just gonna put it here and hope that my linter is working correctly. Yeah, cargo formats worked pretty well. There you go. So here I have something that checks for null pointer, iterates through the string until it finds the null terminating byte, which is an invariant I have actually defined in my documentation. Make sure it's a null terminated string. So we should be fine. And I am mutating the object, okay? So we are gonna have a look at the test I've written. The actual slice is this. We wanna actually, I think it's automatically null terminated, but we might as well just give it a go. Okay, so right now I'm gonna go back to the bencher and add a test and invoke this new function. So here we are. I'm gonna write a new test. The new test is gonna be called to lowercase, of course, to lowercase hello. I'm gonna copy paste it. It's easier. Hello world, no length, and I'm just gonna copy this. So this is the slice. This is the actual slice. This is the expected slice. Now I don't need the length anymore. And I'm going to call to lowercase. Another test I would like to make sure works is what happens with the null pointer. So I'm going to copy paste the null pointer no length test. And there you go. There you go. And that would be net to lowercase with the slice. I need to make sure I have defined it here. So I'm going to go back and show you everything again. There is the function, which I have defined here, okay? There is a test written in Rust, which I have written here. There is this rewrite it in rust.h file, which I told you about in the first episode, which allows me to define the functions I'm gonna use. So that this is where I declare to lowercase. And this one just takes a pointer to a string. And now I can actually use it in my test.cpp. So let's go back. I'm going to make clean. I'm going to make test. All right. I think it works. I think it works. Yeah, it actually does. So this is great. Both tests are passing. We've been able to define that. There's one more thing I would like to show you, which is actually related to what we have done before. I need to find it again. That would be the to lowercase with a length. There is an unsafe function call here, and I want to show you quickly what the documentation says about that. That would be slice from raw part. Let's switch to the internet tab. From raw parts, and that's even the from raw parts mute that I'm using. So it's the same functionality as from raw parts, and it's this unsafe for the same reasons as from raw parts, okay? So that means I'm actually supposed to make sure that the data is non-null anonymized, okay? Even for zero length slices, and one reason for this, blah, blah, blah. And may rely on references, being in line is critical. You can obtain a pointer that is usable as data for zero length slices using null dangling. I actually don't need to because I'm going to iterate over the items. So if length is 0, I'm just going to get out of the function. So that might actually be okay. So, and the other thing is that the total size of the slice cannot be larger than I size : max bytes in memory. So what we want to do here and they link back to the offset, which is pretty closely related. So they link back to the offset and they be like, yeah, let's have a look at iSize Max. So what I'm going to do is make sure that the code I am working on is safe with respect to these guarantees. I've been checking for the null pointer. I'm going to check. I'm going to make sure that the from raw parts mod call is safe. And to make sure that the from raw parts mod call is safe, I'm gonna check the length. That's not exactly what is being told in the documentation, but I actually, if the length is 0, I don't need to iterate over it, so there's no need for me to call raw part mods. Or if len is greater than iSize max, which could actually occur theoretically because it's a usize. So let's do that. And I just want to return. And now this unsafe call, I have actually, can I do that? There's no iSize max. There's probably something I need to import. Oh, no, that was the namespace. Thank you again, Visual Studio Code, I suppose, is it? You cannot convert an iSize into usize. Oh, yeah. I cannot try into, definitely not. If, oh, okay, let's make it another way. So I have a usize and I want to convert it into an iSize to make sure it actually works out. So there are two ways to go about that. As you can see, there is a try into function. Maybe I can try to convert the length into an iSize. If I am able to do that, that means that the length is within the iSize range. So let's do that. Let I len as iSize equals len dot, there was a try into, if I recall correctly. Iflet, I'm gonna iflet sum. I don't remember if that's good or not. Sum, there's no try into for that. Let's if then return. There's probably an into iSize or something like this. I'm not really sure I can do that. No. Let's have a look at the documentation of iSize, okay? So how do I go about that and how do I look for that? I'm gonna search for iSize rustling. iSize min value, iSize max value, and I wanna, is there an into or something like this that I might be able to work on? Max value, min value. Well, the thing is, the max value of an iSize could theoretically be cast, I don't even know how to say it in English, but you could theoretically cast iSize max value if stood iSize dot max value, since an unsigned max value is above an unsigned assigned integer's max value, I can probably do something like this as usize. I don't know if it's going to allow me to do that. Let's have a look at that. No, I'm actually trying to have the compiler help me a little bit in that. That would be iSize max value, I suppose. Let's try that. Oh, now it works. All right. So I'm going to go and say it again so I'm sure it's clear for everyone. An unsigned integer, its max value is going to be above a signed integer's max value with the same size. Okay. So this here can be safely casted. I can cast it into a U size. Okay. So I'm going to make sure that the length is that if it's 0 or if it's more than the max value of a nice size, which are the two conditions that would make it an undefined behavior to call from raw parts mods. If one of both happens, I just want to return because I'm gonna create an undefined behavior. So once this is done, I'm gonna run the test again, make sure I didn't blow up anything in the process. Oh, the bencher does not work anymore, and that's because I renamed a couple of things. So here, no, to lowercase with length. Okay, so that would be to lowercase with length. And I'm even gonna add two new benchmarks, which would be the no length versions. So the two lowercase string no length and the CPP two lowercase string no length, that's hard to pronounce. I'm gonna do that like this, and I'm gonna call net to lowercase, and I'm gonna call net to lowercase without the length. And I don't know if I did copy the C++ site code for net to lowercase. No, I have not. I have not, so I'm gonna copy it directly from the Firefox code base, which is behind. I did not switch the tabs because I don't want you to bother with that, but here you are. So here, I'm gonna try to bench again. Too few argument counts for net to lowercase. Okay, so that means net to lowercase, net to lowercase. No, that's actually okay, I suppose. I'm gonna make clean and make test. Okay, make bench. That's something I don't understand right now. CPP to lowercase string no length. So that's this one. That's weird. I don't really know what's happening, but my ultimate goal is to have the bencher work. So I'm gonna have a look at it after. I'm gonna just do it. Oh, I know. It's okay. I think I declared it here, but did not declare it in the header file. So there you are. So now the bencher knows what I'm talking about. So that would be to lowercase. Let's try that again. Okay, that's better. All right. So there, I'm gonna register the two new benchmarks to make sure that it's being handled. And then I'm going to wrap it up and talk again about the key takeaways from what we've just seen. So key takeaways, there's a couple of things that we need to make sure of when we are using unsafe. When we're using unsafe, it is required that we have a look at the documentation, try to understand exactly what is going on, and what the invariants are that we are supposed to hold on our own. Okay, we need to make sure that the guarantees are not broken. And of course, if you are writing an unsafe API, you need to document the invariants that are required to be held. For example, this here, make sure stir points to an actual null terminated string. This probably belongs to a safety section of the documentation, which I'm probably going to update later. Okay, so this is something that you need to check about. Every time there's an unsafe call, make sure that the invariants are actually held and add documentation on why this call is unsafe and how you made sure the invariants are held. Okay, so that was the first part. The second part is, unfortunately, Rust does not have function overloading. What it means is that you cannot declare two functions with the same name, even though the return type or the parameter types or the number of parameters are different. So the way I went about it was by declaring several functions with different names. And in the Firefox code base, once I will submit the pull request, I will probably have a C wrapper calling the Rust version. And that would allow me to define two functions with different parameters on the C++ side. And then I would call the two differently named Rust functions. I think this is it for now. The next videos are going to be much more fun because they will involve actual algorithms. We won't have to fiddle with the FFI anymore, too much anymore, I suppose. We are basically going to get some strings, and once we have them, we are going to think about the algorithms about that. Um, Let me show you the next topic. It's going to be about rewriting find char not inset and find char inset in Rust. Basically, there will be two parts. The first one will be to convert these pointers to something that we can actually use in Rust, and then we are gonna rewrite those for loops and try maybe to use different data structures um, than what we have here, which is probably not the best thing to do anyway. We'll figure it out. I suppose that's it for now. If you have any questions, please let me know. If you like the video, please share it. Please add a thumbs up and add some comments. And you can always hit me up in direct mentions on Twitter or anywhere. I would be happy to talk to you. If you have any questions, any suggestions, please let me know. Thank you again and see you soon.